All right.
Hello.
Hello, and welcome to the web platform portion of today's content.
Yes, it will be fun about web with a strange accent from foreign countries.
That's
And-
right.
yes.
He's from the foreign country of France.
Yes.
And I'm from the foreign country of Texas.
So after one day of Brits, I think it could be interesting
that's
to
right.
change.
This will be your break from the
Yeah.
British accent.
All right, and today we're gonna talk about two main topics.
First of all,
Yep.
who are you? What's
Oh,
your name?
My name is David Catuhe, Catuhe in France. You can find me on Twitter at DeltaCoche.
Okay.
And my day job is to talk with web developers about Microsoft Edge.
Great. So I'm Jeff Burtoft, and I am Boy of Green on Twitter. And I spend my days talking to folks about building web apps, and
That's why we work together.
that's
actually.
right. That's right.
We use the same engine.
Yeah, so we've got a lot of great content for you today. We're going to start off talking about the web.
Yes, I'm going to start talking about the platform by itself, which is used by all web apps. So that's why we thought it's a good idea to start with the Edge. And I would like to start with a big number. I love big numbers, 44 billion. 44 billion, it's the number of websites out there. So when you build a web browser, you have to be able to support 44 billion websites. That's why creating a great browser is pretty hard, and I need to duplicate my screen, obviously.
It looks like there's something missing.
I'm
There we
already
go.
duplicated, so that's
There
cool.
we go.
And what I want to say here is that having the perfect browser is something really hard and long, and we did an interesting journey from the very first version of IE, and I get back to that quickly. Trillions, another big number. Trillions is the number of URL that we crawl every day using the Bing engine to ensure that our new browser is compatible with the World Wide Web. But before talking about Edge, I would like to step back a little bit. And I would like to talk about history. We were discussing about American history just before, so it's interesting. Part of this history is starting in 1995. In 1995, the web was almost about mosaic, if you can remember, and
I
links,
do,
perhaps for the
unfortunately.
for the order of us. And we decided to ship the very first version of IE.
20 years ago.
Yeah, 20 years ago with Windows 95. It was a long time ago. It's like dinosaurs when we talk about web and computers. We shipped different versions till IE6, where we introduced the very first version of the dual engine, let's say. We call that the document type.
So, David, I don't think we're seeing your screen.
Oh, that's
here. We'll
interesting.
try.
Why? Let me just cut the... no, I don't have presenter mode. Okay, let me move to the next one. For some reason, it doesn't update. Okay. Let's adapt.
Do you want me to present?
Oh, I think I
And
can
you
do
can-
that this way.
Okay.
So
Yep, perfect.
that's okay. Yeah, so 1995, the very first version of Internet Explorer, and we shipped IE6, like 6 version after. At this time, the goal was to keep the backward compatibility with what we shipped before, and also introducing new features. So that's why we decided, why not having what we call now the document type. And document type, you can think about a big if inside your code. If you are in a quirks mode, then you will receive all the new stuff. If you're in the strict mode, you will receive only the stuff for the specific version. It was a good idea at that time. With 2 options, that was okay.
Well, this was also important, David, because the web did not change that fast back then. Right?
No, no.
So if you broke something, it would take a really long time for that site to go back and fix it.
Absolutely.
So that was kind of what was driving the behavior.
And that was,
in early
yeah,
days
as you
of IE.
mentioned, the pace was different.
Yeah.
Then we stopped developing IE6 because it was okay at that time. We introduced ActiveX, a lot of stuff were running on IE, and we were okay with that. We rebooted, or we restarted IE with version 7 and then 8, introducing in this time a 3rd option, like IE8, IE7, and IE5 mode. And the problem was that at that time, it was still okay with 3 versions. But if you go, let's go to the next slide. I'm trying to. With IE9, we introduce a 4th engine. Obviously, with new features like HTML5, SVG, ECMAScript 5, the new version at that time of JavaScript. So the code started to stink a little bit. Like, okay, for every feature, I have a big if, with if IE5, IE7, IE8, and IE9. The idea was still the same, providing new features, but keeping the backward compatibility. And obviously, guess what? With IE11, we knew at that time that we had to do something. We knew at that time that it will not be possible to add, like here, 8 different versions of the engine inside the same engine. It's not viable anymore. That's why, and in the meantime, the other problem was, let me try to go again full screen. No, for some reason, my window just don't want full screen. Okay. And so it won't be easy. But in the meantime, what we have here is the different version of all the browsers. So we went from IE1 to IE11, but in the same time, Firefox, Opera, Chrome had a lot of versions. As you can see here, if you're zooming a little bit, it was from Chrome 1 to Chrome 40 in the same time. The only difference is that they are removing the previous version each time. They are considering they don't want backward compatibilities. Every new version of the browser introduces new features, perhaps break something, but that's okay. That's how the web should work when you are using a modern browser. So, this introduced some issues as well. We had some issues on IE side because you have, as a web developer, to support IE5, IE6, etc. But in the same time, on the mobile space, to be honest, Chromium, which is widely used, has also the same issues because they are not able to control every version on every devices. So we can see as well a big fragmentation. So it's not just a problem for IE, it was a problem for all browsers vendors.
Right.
Hop. Boom. Trying to introducing, it's different when I don't have my animation, I'm sorry about that. Introducing the new Microsoft Edge, and what's the difference is that we have an always up-to-date engine. So that's why we decided to have a new browser. The old IE11 will remain here, and we'll be able to support legacy content, ActiveX, Silverlight, stuff like that. But for the new web, for the modern web, for all stuff related to HTML5, the new CSS3 or 4, all the ECMAScript 6 stuff, you can use Edge, and we will keep it always up to date. We call that evergreen, meaning that it will always be up to date. Okay? So that's interesting for you as a web developer, because if you want to develop for the web, you just have to target the latest version of Chrome, Opera, Firefox, and Edge. Okay? So, the new browser was obviously for us, the goal was obviously to support the web, the World Wide Web, but also to add new features and even new performances. We did a really tremendous work on the Chakra engine. The Chakra engine is the JavaScript engine that we have inside Edge. And as you can see, Benchmark now gave us the first place on Jetstream and on Octane. Interestingly, Octane is from Chrome, so it's interesting to see that even if we use the competitors' benchmark, we are almost doing the same game, let's say. Chrome, Canary, and Edge are almost the same performance. So now it's not a performance issue if you want to use Edge. You can use Edge and have a really fast web.
It's important to point out that we don't code to performance engines, or to performance test, right?
No. That's a good point.
We do look at them as a way to kind of give us an indication that we're moving in the right direction.
Yep.
So we don't write code that specifically performs well on these tests, but it's great to run them afterwards and see that we're especially doing leaps and bounds better than what we did before.
Yeah, and it's really important that you mentioned that. We don't want to tweak the test. That's really important. We want to be able to have a really performant JavaScript engine anytime, and obviously when we use benchmark as well. Other point that we introduced with the browser is clearly an open door, not an open door, but clearly a door to your computer. You go to a website, and perhaps if you find some malicious website, they can try to hijack your computer. So with Edge, we decided to provide a really secure environment. Browsing the web with Edge should be really safe for you guys. So for instance, we introduced three big features. The first one is the App Container Sandbox. The App Container Sandbox is a space, is a sandbox, a client app sandbox provided by Windows. When you run inside the sandbox, Windows itself will guarantee that you cannot reach the system. So even if someone finds a way to hijack Edge, they will remain inside this secure box. So no risk for your computer, for your hard drive. The second point is that by default, Edge is a 64-bit process. And 64-bit process, because thanks to Windows and to Intel, get significant security advantage. They, for instance, use a different address space for the memory. So it's kind of tools that you don't need to know about, but that they are used by Edge to protect you. And finally, we use a different way of handling the memory in a way that we are now using a garbage collector. So every memory leak and every way to enter to your computer by using the memory are now controlled by the memGC, which guarantee that you as a web developer or you as a web user, you are okay, you are safe to browse the web. Okay? Moving to the next one. We also worked on, we can say, fancy or funny stuff. The web today is working in a way that you, as a web platform, as a browser, you have to identify yourself on the server side. Mm-hmm. You have to provide an identity card. Hey, my name is Edge. I'm running on Windows NT 10, which is Windows 10, and I want to download a page. On the other side, the server will identify you and say, okay, you Edge, I can give you this, because I know that you Edge support these features. That's not the way things should work. The server should just send back content regardless of who is asking for this content. Mm-hmm. And that's the responsibility of the web developer to do what we call feature testing, meaning with JavaScript, for instance, you try to say, okay, I want to use web audio. Is web audio supported? It's not the case. So today, on the server side, some websites are sniffing the user agent string, your ID card, and are trying to send you different content based on this ID card. Okay. No worry. That's why we decided to change our user agent a little bit. And as you can see here, it looks like Chrome. Because today, the fancy browser, let's be honest, is Chrome. So we want to receive exactly the same content. We want to receive the modern content because we can handle it. So, and that's not new. As you can see here, all the red stuff are lies.
Right.
Yeah. For instance,
so you're telling me that not all the browsers are Mozilla 5.0?
No. For instance, no. They are not
Shocking.
Netscape. They are not
Shocking.
Netscape, man. And for instance, Chrome is using Apple WebKit, was using Apple WebKit, which is not true right now. And Chrome is not Safari. And what I can say, Mozilla here is Firefox, sure, but Gecko, it's not the right stuff. You see what I mean? Everyone played this game at some point in time. Mm-hmm. For the final user, that's really interesting because now, if you are using Edge, you will receive the correct content. You will receive the very latest version of the content because even if the server is sniffing the UA, they will consider us as Chrome, meaning the fancy browser, so we will receive the right content. By doing that, we move from this state where, and we are on the mobile space, which is worse because on mobile space, it's mostly about WebKit. Mm-hmm. So for instance, on the left, we have Firefox OS. On the middle, we have Safari on iOS. And on the left, we have IE Mobile. And as you can see, only the iPad version is receiving the right content, or the iPhone version is receiving the right content. On the left and on the right, we don't have the right one. It's mostly something about the desktop version. They are sniffing the UA. They don't find a Chrome or WebKit identity card. They send us the desktop content. You're not the mobile. Now, because we are playing the game of the user agent string, we are receiving the right content. That's it. And for the end user, that's cool because you receive the right mobile version when you're on a mobile and you receive the right desktop when you're on desktop. So that's cool. But it's not just about performance and security and compatibility and interoperability. That's also about new features.
That's right.
New features. We did a huge work on new features. More than 4,000 interoperability improvements. So it's about fixing bugs, obviously. We add bugs. But we forked the code from IE. We removed all the IE specific code to keep just the basic and the fundamentals. And we built on top of that to add new features. So as you can see here, ECMAScript 6, web audio, get user media, HTTP2, gamepad, blah, blah, blah.
So the features that web developers have been asking for the most.
And that's a good transition. Thank you very much. Because if you are a web developer, perhaps you want a specific feature that we are not supporting so far. So what can you do? You can go to status.modern.ie to ask for this feature. And perhaps someone already asked for it. So you can vote for these specific features. And you can see, let me just open here, status.modern.ie. And you can see here, and for instance, I moved to the new version. Cool. I want to check the status of a specific feature, like for instance, ASM.js. Are we supporting ASM.js? Yes, we are supporting it on Edge. That's cool. And we also have different status, like it's in development. So a further version will support it. That's excellent. And then we are considering, for instance, adding support for battery status API. And if it's something that you want, that you really want, you can vote and add your voice to this specific feature. And we, as a program manager, when we decide to support a new feature, we go to this site and say, okay, a lot of people ask for beacon.
Yeah.
Not bacon. Beacon.
Not bacon.
Then why not supporting beacon, okay? That's the way we want to work with you guys. This is our public roadmap. And you can, if you want, add your voice to a specific feature to have it implement in a future version of Edge.
And this is something that developers have been asking us for
yes,
some time.
Obviously,
they want a place to go and find out what is supported, what's on the roadmap.
That's obvious because when you're a web developer, you want to create a website and perhaps you want to use a specific feature. You want to have a glimpse at should it be supported a lot or should I think about perhaps having a polyfill or something to deal with that. So that's why status.modern.ie is your one-stop shop where you can go to support a feature or check the support of a feature.
Or vote it up.
Yep.
Tell us that you want it.
Other point really important here. With Edge, we moved to a about flag approach, which means that we will keep adding new features. And to allow web developers to test these new features, instead of working with prefixes like all the browser vendor did before, we decided to go the about flag way, like Chrome and Firefox, for instance. Let's go to my Edge again. And if I'm going to about flags like this screen is something for advanced users, to be honest. And this is where you can enable specific features that we are working on. And you want to test, for instance, CSS filter. Just click this checkbox here, restart Edge, and CSS filter will be available. That's interesting, because as a web developer, you can test, but we won't publish it inside the mainstream version of Edge, keeping the mainstream version of Edge safe.
So instead of doing the browser prefixes, like we had in the past, now the flags, so it's in the user's control instead of the developer's control.
Absolutely, and that's the point. As a web developer, when I create a page, if I want to use a specific experimental features, before I had to add, for instance, -ms, -gradient, -webkit, -gradient. Most of the time, that's cool.
Yep.
When these features become an official feature and all the browsers implement it, you, as a web developer, have to think about removing the prefixes and just using the unprefixed one. But
no one ever did.
Yeah, we are all developers. We are all lazy. That's
right.
not a problem. And we forgot about that. Oh man, I forget to remove my dash something. And that's one of the main reasons why the web sometimes break, because people forgot
Yep.
about that.
And in this scenario, they're feature detecting.
Yep.
So they, first of all, when it's experimental, only the folks who have those flags on will get the feature.
Yes.
But as it's adopted and more browsers support it, more people
It
will
will
get
become
that
the
feature.
main path for the code, or most of the time, yeah, the feature
Right.
detection will return true. So that's fine.
Better for users, better for developers.
Yes, that's better even for the web in general.
Yeah.
So we also added that to Edge. And I think I would like to show you just two interesting demonstrations,
Let's do
and
it.
we can switch to the Windows web platform. Among all the features that we added to Edge, like as I mentioned before, 4,000, I picked only two because I know we don't have all the day for that. The very first one is WebGL and Web Audio. I have here a wonderful website called babylonjs.com. It's a 3D engine only based on JavaScript. Nothing else than JavaScript here. And I'm going to show you what we can do today with just my browser, a modern browser. And we have a question. As a browser, I don't want video to automatically play. Is there a way to control this in the Edge browser? It depends. It depends. If you're on YouTube, for instance, or Facebook, I don't think you can control that.
Well, it's in the developer's control.
Yes.
So, Derek, if you're the developer, you absolutely can control that. But I think you're asking as a user, is there a way to turn that autoplay off?
Yeah. That's part of the control. When you use the HTML video control, you can say autoplay if you want, you as a web developer. So your users will always have autoplayed video. My response for this specific question is no, you cannot, as a user, control how Edge will handle autoplay. If it's an order from the web developer, Edge will obey.
Yeah. Well, good. I think that's a good feature request, though.
Yeah, you should
submit that
go
the
to
guys and-
status.modern.ai and ask for having user control option to block this feature.
Yeah. I think we would all appreciate that.
Yeah, yeah, mostly on Facebook. Yeah, so this is a demonstration I have, and this demonstration is interesting because there is no plugin, once again. And I have a small PC, it's an X1 Carbon. It's an i7 with no GPU card, it's an Intel HD card. So something really basic.
Yeah.
And as you can see here, I have a full 3D experience where I can wander around. I have this wonderful manor where I can just try to wander. And the interesting thing is that I have discovered something for you guys. For instance, I found Clippy. Clippy is dead, guys. He's just there. I can see his ghost. So that's cool. Clippy is dead. And you ask for that, guys. I mean that all web developers in the world ask for that. Yes, IE6 is dead. And when I click on this tombstone, I can see that now the future is about Edge. Boom. So this demonstration is just, I'm not sure there is sound, and there is sound in my demonstration here because we are using WebGL and Web Audio, and can also enable, for instance, the gamepad if I want to play with my gamepad. So if you go to babylonjs.com, please try it with Edge, or obviously Chrome, Firefox, or any modern browser. That's the power that we have today in our hands with just HTML5 and JavaScript. The other demonstration I want to show you guys here is more about the language by itself. With Edge, we have now more than 80% coverage of all the ECMAScript 6 language. ECMAScript 6 language, besides the fact that it's hard for me to pronounce, is the version of JavaScript, let's say. And with ECMAScript 6, we added a lot of cool stuff. For instance, we added classes, we added generators, we added a raw function, we added so many cool stuff. And I want to show you something really interesting. Here I have TypeScript. Why TypeScript? Because TypeScript is a great tool for you guys to start learning JavaScript and the web without having to deal too quickly with all the weird stuff of JavaScript. Here I have a TypeScript code with a class where I define a constructor, and I'm using and instantiating this class. On the right part, I have the JavaScript pure version. So this JavaScript pure version obviously does not use class, does not use constructor or whatever, and is purely based on prototype. Okay. So if I'm just copy pasting this code and I want to use that on my JS fiddle here, purely JavaScript code, I can run it, and I have my button here. When I click on say hello, guess what? It's saying hello.
Hello.
Cool. Purely JavaScript. This works anywhere. Now, yes, leave this page and try to load it again. Let's consider copy pasting the TypeScript version this time. And because I'm on Edge, I'm using Edge, I will just remove one little thing here, which is this, the description, the type. JavaScript is still untyped, but beside that, I just keep everything else. I'm keeping the class, the constructor, all the instantiation remain the same, and I'm hitting run. Guess what? That works. This is valid JavaScript. Because with Edge, we are supporting ECMAScript 6 and all the new cool stuff that we have inside it. Be prepared as a web developer to learn ECMAScript 6. There are so many wonders in it, and obviously Chrome, Firefox, all other browsers are also working on supporting it. So like perhaps in 1 year and less than that, all the modern browser will support all this version, and you will be able, as a JavaScript guy, to write this kind of code. So please try it.
TypeScript lets you do it today,
Yes.
right? And that's one thing is to point out is that TypeScript works in all browsers.
Yes, with TypeScript, you can decide to generate code for ECMAScript 5, which is the standard version today, but you can also ask to support ECMAScript 3, the old one.
Right.
So, because everything can be easily adapted to use prototyping, that's the power of TypeScript. But with ECMAScript 6, TypeScript will start becoming something almost useless, because everything, or we can just use almost some kind of TypeScript inside our browser. That's cool. I'm really happy about that.
Awesome.
So hopefully you won't have issues with your slide.
All right. I'm going to need your
Yes.
connection there. Okay. So for the web platform, I could easily just say everything that he said, because that's the way that the web platform works today, is that it's built off of the same web technologies that we have in Edge.
The same platform.
So let's see here. So anytime in Windows 10, when you're using a web component, whether that's inside of Edge or inside of a hosted web app or a packaged app, it's all using that same rendering engine. So this is a window in Edge today, right? And it's running off of, you mentioned the Edge HTML rendering engine. So that's the new rendering engine that has all of those new features, all of the interoperability fixes inside of it. And then we also have the new Chakra engine, which runs JavaScript blazingly fast. Now that we've
ECMAScript 6.
ECMAScript 6, we put all of that IE specific code, and we end up with a super fast JavaScript engine. So those same engines are what is inside of a JavaScript app. So the great thing about that is, you know, if your code is going to run inside of Edge, then it's going to run inside the app the same way. So it also means every time we get a great new benefit inside of Edge, we get that same benefit inside of the JavaScript app.
Let's say we will support, for instance, ORTC. It will become available for you.
It'll be available for you in the apps as well.
Cool.
So that means as a web developer, you're writing your code for the web, and you can easily transition that into the app space. So that's kind of what we're doing here with Windows 10. Apps in the web become a lot closer together, right? We're starting to see those things blend, and it makes a fascinating opportunity for web developers. So there's a few different ways that you can present your code inside Windows 10. First of all, you can package the content. And this is something that we introduced for Windows in Windows 8, where you can take your JavaScript, your HTML, your CSS, and basically put it inside of a zip package, and then that's what is submitted to the store by the developer. The users go and download the app just like they would a C# or C++ app, and they've got all of that code already on their system. So it's great. It's generally offline first, so anything is running off your local machine. It's making service calls for your your content. We also have a new model in Windows 10 that we call the hosted web app. And you might also hear us refer to it by its code name, which is Project Westminster. And it's really a way for you to take the code that's living on your web server and turn that into an application. Yeah. So
write once and deploy really anywhere.
Really anywhere. Yeah. So you can think about the fact that with a packaged app, if you have a single page application that packages offline, you're in great shape, but there's a lot of sites out there that run on Node.js as a backend, or PHP or Ruby, ASP.NET. Any of those languages can now be used to write your Windows 10 application. Well, we'll talk a little bit more about that in a minute. The third thing is that you can always choose to mix it up. And you can have some of your content local and some of it on the server, or some of it on the server and some of it local, and transition between the two. I mean, the web view lives in that space as well, because that's something that can run local and point to content on the web server and vice versa. So I want to talk about a little bit about packaged apps first. The really great tooling features that we have inside of Windows 10 is around Apache Cordova. So Apache Cordova is a way for you to build these packaged JavaScript apps and deploy them cross-platform. So this isn't a solution that is just for Windows. Cordova runs on iOS, on Android, and other platforms as well. Well, Visual Studio now supports that as a first-class application type. So it's, in my opinion, the very best IDE for building Cordova apps. So within
even with the emulators, they are blazing fast.
So Visual Studio has its own Android emulators as well, which work significantly faster than what I get whenever I'm running on the Google tools.
Yep.
So it's a really great way to build your applications to help your web code that's probably already built to be cross-platform, ship across platform as well. So that's built inside of Visual Studio 2015. That's just been released, and works great on Windows 10 and even older versions of Windows, as well as iOS and Android. So the next thing I want to talk about is that WebView tool that comes in very handy. We find out that a large majority of our applications inside the Windows Store utilize a WebView at one point or another, because it's really common to make your application out of a web view, or make a portion of your application or just one section of your application point to a website and run the code off a website. Or there's some things that just lend themselves more efficiently when they're written in web code, and you can use the web view inside of a JavaScript app or inside of a XAML app to point to web code. So we have a lot of new and exciting features inside of the web view. We have a number of performance gains. We've separated the web view off the UI thread so that your application as a whole doesn't get slowed down whenever your web view is loading. Improved performance and responsiveness. Web view communication. I'm going to show you in a minute ways that you can communicate between the code inside your web view.
This demo is cool.
And the code that is living in your application, the native code, whether it be C# or C++. And then also access to the Windows runtime. So when you're inside of a native app, you have all of these Windows APIs for things like Bluetooth and live tiles and toast notifications and low-level hid info and that type of thing that you could always access as a store application. Well, your web view can now have direct access to those APIs. So no longer do you have to build a bridge code that takes some code inside the web view and some code outside the web queue and communicate through notifications and things of that sort. Let's go ahead and do a demo here. So I'm going to open up Visual Studio. I actually have this project open. And I'm going to show you what I have here. If you notice, this project has a JavaScript project in it, and it has a C# project in it.
Yep.
All right. So web developers, don't get scared. I'm going to open up some C# code. I'm sure there's a lot of C# developers out there, or C++
I'm pretty sure that on Channel 9 we have a lot of C# developers.
That's right. That they might be really interested in understanding how we can really easily interrupt between the web code and the native code. So inside of here, I have a class I call Communication Win RT. So I'm going to open that up, and what you're going to see inside of here, you're going to see a couple classes, Communication Win RT, which is going to have inside of that camera, and then one that I call communication. So camera will give you access to the camera from the C# class, and the other one will give you access to toast notifications to the C# class. All right, so that's in my C#. And now inside of my app here, let me go ahead and open up the JavaScript side. I'm going to open up my default.html, and what you're going to see here is a web view, right? So I have a web view on this page, and the web view has an ID of web view. Very creative. That's how I.
Yeah, I like your name.
I love the creative names, you know, expression. And then inside of here, inside of my JavaScript, you'll see I'm doing a few steps here. The first thing I'm doing is declaring a new instance of my native classes. Okay, so you can see I have a new instance of Communicate WinRT and a new instance of Camera WinRT. And then I'm using this new method called Add Web Allowed Object. All right, so what this does is it lets me take that C# class and expose it into the DOM of the web view. And at the same time, I get to decide what I want to call it, right? So I call it Jeff Rocks. I just couldn't think of a better name.
That should be obvious.
For a new API than that.
You're right.
So Jeff Rocks, and then my camera is another one. And then I'm just going to go ahead and fire the web view to navigate. So there's one other thing that I have to do before that. And I have to go ahead and enable access to the web view to this code. So that happens inside of your manifest, and it's very easy to do. So you'll see here in my content URIs, I'm giving access to what I call MS AppX Web, okay? And that's giving them access to WinRT access for allow for web only. Okay, so I can choose to do none, all, or allow for web only. Now I want to point out what I'm doing here with this protocol. It probably looks a little foreign for web development, but when you're inside of Visual Studio building applications, you actually have different ways to associate your code inside the app. So you can use different security policies. One of them is the regular when you point to just the file, and that's going to be inside of the app context. Yep. And that will have a default CSP security policy that does things like blocks script from executing in the page. They all need to be in external scripts and things like that. If I want to move into the web context, which is going to be the default whenever I'm pointing external to the app, I can do that by saying MS AppX Web. Okay, so that just points to that, which has no default security context, and then I can assign programmatically access to those APIs. All right, and the reason why I'm doing that is because I'm pointing to a page inside of my app. All right, this could just as easily be out on a web server here.
And you have the API, Jeff Rocks.
That's right.
Wow.
So this is going to be the code that would run on my server, or in this case is going to run from this local page. It's going to be checking for an object that says window.jeffrocks. So let's go ahead and run this. And I think I've got a breakpoint set up already, so. Wait for it to load here. Okay, so it's running my application. And then I'm going to go ahead and hit the button that's on the page. Oh, I don't have a breakpoint, but you'll see what happens. It fired a toast notification. So let me set up a breakpoint so that we can see what's happening here. I'm going to go into that page.html, and I'm going to set a breakpoint right here so that we can inspect the object. All right, so I'm going to hit the notify button. And when I get caught here, I'm going to look at object, and you can see it's looking on the window object in the DOM. So since I've added that new API that I call Jeff Rocks, you'll see it appears right here on the window object. So I see window.jeffrocks, open this up, and I'm going to see the method that I have there, the toast message.
Wow.
Right, so that's what I named it. So I'm checking to see if that object exists. I'm feature detecting. And if it does, I'm going to go ahead and then fire off object.toastMessage, which I'm going to pass in the text hello world, right? And then 0 because there's no time delay for it. And that's actually going to call my C# code where I have the code for the toast notification.
The best of the two worlds.
So I'm creating my own API with native code here. Let's go ahead and continue. See that fire again, and there's my toast notification. So that's an easy way for me to create custom APIs inside of the web view and communicate very easily between JavaScript and the native object. All right. Okay, so let's talk a little bit now about the hosted content. One of the great things about your hosted web content is that it's always up to date because it's pointing to your code on the web server. We call it hosted because with the hosted web app, your code is hosted on your web server.
Wow.
So I know, another incredibly named product there, but it's really upfront. So this is how our hosted apps work. You have your store application, which when it fires up, it goes out to your web server and pulls that code down to execute inside of the app context. It's just like a browser.
Yeah, it's like your own little browser for your own website.
Right. So a browser, you know, you type in the URL and then it goes out to the web server, pulls that code down into its memory, executes it, and you have your web app. Same thing is happening inside of the hosted application that the user downloads from the store. So the great thing about it is you don't have to make any changes to your code to have it run. It will literally run just like it does in Microsoft Edge. You don't have to change your workflow. You don't have to submit updates to the store anymore. You just make changes on your web server, and the next time the user loads up the application, they're going to see that new fresh content.
That's freaking cool.
It's a store application, so it has its own memory footprint. It has its own cache that it doesn't have to share with other applications. It's sandboxed and secure just like the other store applications. And one of the greatest things is when you're inside of that safe environment, we can give your app access to all of the Windows runtime APIs. So that's everything, and I'm going to show you a few examples here. We're going to see toast notifications, we're going to see live tiles, and calendar access and contacts access, but that's just the tip of the iceberg as to what your hosted application can enable for your website code. So for all the web developers who have been asking for this API and that API over the years that we haven't been able to work in the browser yet, now inside of a hosted app, you can have access to all of those. All right, so we're going to start off, and I'm going to do a demo here of a hosted web app. So we will often call this Project Westminster. You'll hear it referred to. And this is one of our bridges that allows you as a web developer to take the code you've already written and bring it to Windows. So I'm going to start out with this application here, and this is what I call Bank of Contoso. Okay. So it's an imaginary bank. It's where I put my imaginary millions.
Yeah.
It's a good place for it. And
can you handle mine as well?
I could handle yours as well. So this is a typical modern application. You'll see it's responsive. Yes. It has works well on the phone size screen as well as your desktop. I'm going to go ahead, I can see my accounts here, my account information. Also, I have things that you would expect from an app, like your notifications are hidden in here and things like that. So I want to be able to take my Bank of Contoso app and move it into a hosted web app.
Cool.
So it's just a few steps here, and I'm going to impress you all with how easy it is, okay? So the first thing I want to do is grab my URL. And now if you have Visual Studio installed, you go and you open up a blank JavaScript application, all right? And we're going to call this my new hosted app, all right? And it's going to generate a blank application for you. Now remember that your code is running from the server, yep. So you don't really need to have this package code inside of here. So I'm going to take the CSS.
Yeah, no need for any local offline code.
That's right. All this stuff, and I'm just going to delete it. Obviously, I could leave it there, and we even have the ability to be able to run code from the package when you're offline so that you have a fallback for an experience when it's offline. But in this case, I want to make sure that we're clear this code is running from the server. So I've already got rid of those. I'm going to keep the images because these are things that load prior to a network connection, right? Yep. We want the tile to appear on the user screen, so that's inside the package that you get from the store. We want a splash screen, things like that. So we're going to leave those images inside the package. Now I'm going to open up the manifest, and the first thing I'm going to do is I'm going to take my start page that was pointing to a page called default.html, and I'm now going to point it to Bank of Contoso. Okay, so this Bank of Contoso is it's living on my local machine here, and I have a host override for it. Okay, the other thing that I want to do is I'm going to go into the content URI rules, and I'm going to create a rule for Bank of Contoso that tells it to include it inside this app. Now you can think of the content URIs as being the white list or the scope of your application. So you can think about the fact that in Bank of Contoso, I don't want links that go off to, you know, in this case, a credit card ad or something like that inside of my app, right? I would want that to open up inside the browser. So that's what we're doing. We're defining where the app stops and the internet begins.
So any URL outside of this one is outside of your app.
That's right. It opens up in the user's default browser.
Okay.
All right. So I'm going to go ahead and run this. And now magically, we will have a Bank of Contoso application.
And I can deploy it to the store.
I can deploy it to the store. So that's how simple it is. It's the same code that's running here. Now, one of the things that I mentioned is the ability to access all those WinRT APIs. So with this, I've done no changes to my website. I've just deployed it as it is inside of the application. Everything functions just as it did before. But I actually want to show you what would happen if you include Windows API code. Now, I have added an extra file here on my website, and I call it windowsapp.js. You can call it whatever you want. But you'll see what I'm doing inside of this file is I'm feature detecting for window.windows.
Okay.
Okay, so it's in the window. If we have an object called Windows,
that you know you're on a web app.
Yeah, that's my API service. I know I'm inside of a hosted web app. All right, so inside of here I have a few functions that are going to do things like create a toast notification. It's going to do live tile. It's actually going to make some changes to the way that the tile bar looks as well on my application. Now, in order for me to be able to access those APIs, I've got to expose them to the API surface. So I'm going to go back into my manifest here, and inside the app, remember we talked about this rule here. Well, there's another value where I can say I'm going to give the WinRT access to all. So this is an expose that Windows object inside the DOM. And now when I fire, that feature detection will find window.windows, and it'll execute the code inside of the if statement. So let's go ahead and run that. Let's see what it looks like. I think I might have forgot to save something. Let's try that again. Okay, Bank of Contoso. This needs to be all.
All, yes.
Now we'll fire it again. All right, our new improved experience.
Wow.
You can see the title bar now matches the color of the side. I have this toast notification pop in here. Remember we had that toast hidden up in the DOM before. Well, this is a way for me to now use the native UI here. And this is an interactive toast. It's asking me would I like to update my contact info. If I would dismiss that, the user is always going to be able to find it back here in the Action Center. Yeah. So I'll go ahead and say, yeah, I'm going to go ahead and do, you know, this is not my real phone number. Don't try it. Go ahead and say, yeah, update that info, and it'll go ahead and do that. So I'm able to upgrade the experience for the notifications. You'll also see I have this new section of my app. So this is something bill pay that I didn't have the APIs to create before with the calendar access. Now I do, so it goes ahead and I'm able to alter my DOM and show the link into that application that works when you're inside the hosted app.
Great.
So it's a really great way to upgrade your experience. Using Visual Studio to build an application quickly from the website, the awesome web app that you already have. All right, now we've also want to work with the standards bodies that are out there inside the app space, just like we do in the browser space. There's a W3 standard called the Manifest for Web App that we participate in as Microsoft. We're quite fond of, and we actually support this as a way to create web apps. So you can build the W3C manifest and add it to your website. And then we have a open source community framework that we call Manifold.js. And Manifold.js, supported by the community, we have a number of folks inside of Microsoft and outside of Microsoft who contribute to make this happen. And Manifold.js, based off the W3C standard, you add the manifest to your website, and if you don't have one, you can just run it without, and we'll create one for you. And then it will generate that Project Westminster, that hosted web app for Windows 10. But not just for Windows 10.
Yeah, I was asking, and what about iOS, Android?
That's right. This code runs on all platforms. So we want to have the apps to run that way as well. So Manifold.js generates hosted web apps for iOS, for Android, for Windows 10, even Chrome OS and Firefox OS as well.
Wow.
Now some of those apps, or some of those platforms don't support hosted web apps natively, so we use Cordova to polyfill for it. So it's really great, instead of having to build a separate application for each of those platforms, you as a developer can build that W3C manifest, and then we will generate those applications for you. All right, let's see what that is going to look like here.
I like your logo.
You like the logo?
Clearly.
He's cute, right?
Yeah, it's so cute.
All right, so I want to start out with a different application. This, we went to Bank of Contoso to put our millions of imaginary dollars. Well, I'm going to spend a little bit of that imaginary money on an imaginary trip. Okay, this is going to be an amazing trip, and I'm going to go and do that at Contoso Travel. Okay.
I'm a little bit disappointed. There is no Paris in your list.
You know what? I don't know. Maybe $1 million imaginary dollars isn't enough.
Enough to go to Paris. Yeah, you're right.
So,
that's why.
Yeah, it looks like I can't even get out of the United States apparently. So, what you do here is I'm going to choose my destination, and then I'm going to pick some dates. I think I'm going to go for a good long time here, David. Take some 2 weeks there, and then I can decide, you know, who do I want to go with me? You put their name in there, and we'll send a confirmation, and then you can add it to your calendar, and a calendar pops up, and then we can do that. Okay, so this is a great web app, but since it's such a spectacular web app, it'll make a great store application as well. And again, this is a great experience on all the different devices.
Responsive.
Keep in mind, just like Edge, these Windows web apps run on all the Windows platforms as well. Okay, but we're thinking cross-platform here. So it's not just about Windows. We're going to generate this web app for all the different platforms. And so to do that, I'm going to use Manifold.js. All right, so I'm going to go ahead, I'm going to use the HPS version here. So I'm going to go ahead and open up, first of all, let me show you what I have on my website here. I've already added the W3C manifest, okay?
Okay.
So this is what it looks like. It's basically a bunch of metadata about your site. So it has the start URL, right? That's where I want my web app to start, the landing page. The name of it. The icons are going to list the different icons for the different stores, so that I have the live tiles. I want to make sure I have icons for iOS and Android as well. All the apps want to set the splash screen image. I have my whitelist here, and this is important because remember how we talked about scope for the Windows app. We also want to make sure that in the other hosted applications that we are giving access to all of the API, or excuse me, all of the URLs that we need in the app, and not the ones we don't. And then, you know, display and theme color and things of that sort. So this is already out there on the Contoso Travel website. So what I'm going to do is I'm going to open up my window here, and I've already installed Manifold.js. It's quite easy to do. It's an npm package. So you install Node, and that's all you need to do. You can npm Manifold.js, and you know,
URL.
It will install that for you. But now what I'm going to do is I'm going to run Manifold.js. So Manifold.js, and then I'm going to pass in the URL to that website. And I'm going to do one other thing this time. I'm going to turn on the debugging so that we can kind of look and see what's happening in the background. So that's all I need to do. I just pass in the URL, and Manifold.js is going to do the rest. Okay, so first thing it does, I can scroll up here and show you, it goes out and connects to the site, and it pulls down the manifest that's already out there. So I showed you that manifest. This is the same one. It pulls down there. It'll give me warnings for things like images I'm missing. It's saying, hey, you're generating for a Firefox OS app and you don't have all of the icons. You're going to want to include those. The great thing about Manifold.js is it's not going to stop from building those applications. It'll just put in placeholders. If you're missing anything, it'll generate that. Now, like I mentioned, I already have the manifest on this site, but you don't need to have one to run Manifold.js. You can start out by running Manifold.js, and it'll generate your W3C manifest for you. Okay, so I have my applications ready here. Contoso Travel. Now, when I do this, list the folders inside here, you can see each of the different platforms that I've created for. All right, so I have my Android code here, and this can open up right in Android Studio, or you can use Visual Studio to run it on a PC. My Chrome application, my Firefox application, iOS. Now, what I'm going to do, I'm going to show you Windows 10, what that looks like here. So I'm already in the application. I have a keyword, Manifold.js run Windows, and that's going to install that on the Windows machine that I'm using right now. Okay, so Contoso Travel here.
I want to give him a hug. It's so cool.
He is. He's cute, isn't he? So now I have my travel app running as a Windows app. Yeah. All right. So I'm going to go ahead and run this here. Now, I've given myself access to those Windows APIs, and I'm taking advantage of some of them here. So I'll go ahead and my mouse stopped working. Choose my dates. All right. The next screen. The next thing it's going to do is ask me about choosing a friend. Now, before it provided me a place to type it in. Now it's actually going to open up my contacts and pull from there. I have to choose my wife. I think she'd be upset if I chose someone else to go on the trip with me, and I want to go on the trip with her. It's not that I have to choose her.
Obviously.
Yes. It can then actually open up your calendar, and you can say, yeah, I'm going to go ahead and add this to my calendar so that I don't miss it, and it tells me to enjoy my trip, right? So we have the ability to augment that experience with things that utilize or require those Windows APIs. Now, I'm going to, I don't know if you guys can see this in the center camera here or not, but I'm going to actually show you, we have this running on
Android
yes, and iOS as well. So I'm going to go ahead and open this up and kind of show you here. Good. So I have the Android version here of this application running. Same experience on iOS. And these are ones that were generated by Manifold.js. And then we just run them directly on the app, or directly on the devices. So that same web app are now native applications for all the different platforms. So that's something that's really exciting about working with Microsoft right now, is that we're trying to help you solve your epic problems. And developing one app that works on all the platforms is clearly an epic problem.
Yep, I agree.
Now, we hear from partners, and we've seen third-party studies that tell us that more and more companies are turning to the web as the solution for their cross-platform code. There's many other great options for developing code that runs cross-platform, but more companies are turning to the web. This is a way that you can keep that same web workflow that you have today, the same code, no matter what your backend is, build those applications, and then go out and you can use Manifold.js to do the heavy lifting. You just focus on your application, your W3C manifest for web apps, and then Manifold.js does the rest.
That's huge, man.
So pretty exciting stuff.
Yep.
A few URLs for you to go out there and visit. About the web platform on Microsoft, Microsoft Edge info, where to get Cordova, Manifold.js, and a link out to Project Westminster as well. Cool. So in summary, we've got this great new browser that is the basis of a great web platform here at Microsoft. We want to see you bring your apps to Windows take advantage of all of the different platforms, capabilities that you have. Try it out in Edge. We're sure that as a developer, you're going to enjoy using it and enjoy writing for it.
Don't forget to go to status.modern.ie if you want a specific features. We want to hear about you guys.
All right.
I think that's it. We have no questions. We were crystal clear.
That's right.
That's right. Thank you very much.
Yep. Thanks.
Bye-bye.